All right, let's talk about long division. So if we take a look at a question like this, we learned how to long divide right when we learned to multiply numbers, in grade school. So let's see if we can long divide these numbers and see what parallels it has to dividing polynomials. So 12 goes into 67 only 5 times. So we put a 5 up there. We multiply those two and get 60. We subtract and we bring down. 12 goes into 72 6 times. So we multiply, subtract, bring down. So what we just discovered is 172 is 12 times 56, which for factoring is perfect because we're taking a big number and breaking it down into 2 factors. So why should we long divide polynomials then? You can see a little taste of that over here, and we're going to do practice. But that's kind of what it looks like. And yeah, it's great. We divide things, but why? The whole point is just like we saw up here, is to take a bigger thing and break it down to smaller things multiplied together because they're easier to work with. So we really want to factor those large polynomials and rewrite that form. So for example, for this example here, x squared plus 9x plus 14, this number here, our polynomial there, can be broken down into what you divided it by and your answer. So if you know what to divide by, you can use long division to factor, just like we've been factoring quadratics and cubics. So let's take a look then at the steps of long division. So what you want to do first is you have a dividing question, which says how many, and I'll write it over here, how many times, or what do you multiply x by to get x cubed? We really center our focus on this one when we ask the question. And we're going to the first one, and well, x times x squared is x cubed. So we put an x squared here, just like we did on the last question. We multiply, just like we did. So you multiply x squared times x and x squared times 3x. X squared times negative 3. Put that down there, and then you subtract. And you have to subtract both. So this cancels, right? And negative 4x squared plus 3x squared is negative x squared. Okay? And then we take this down. And then we ask, what do you multiply x by to get negative x squared? And the answer to that question is negative x. So you put that up here, multiply that, subtract, which the first thing should always cancel. If not, you pick the wrong number or term. So 15 minus 3 is 12. Bring this down, and then we ask one final question. X times what is 12x? And the answer to that is 12. So we put a plus 12 here, and we get 12x minus 36. And when you subtract things that are identical, you get 0. So therefore, that cubic is really equal to x minus 3 and x squared minus x plus 12. And sometimes we get lucky, we can factor it even more, because it's already great. We already broke this down into 2 very simple polynomials rather than a big cubic. And sometimes we can take it a step further, and this one can be factored into this. Or can it? Maybe not. I thought this might be true, but it seems like the signs don't match up, because this would need to be a negative 12. So maybe not, but close. Seems like this is as far as we can go. But it is, it's powerful because we don't, with cubics, it's kind of unfamiliar territory, right? So at least this is something that we can use to factor those. Factor by grouping can work with cubics, but only a handful. Let's try it again. So x times what is 2x squared? 2x. Multiply. So did I finish my steps? I don't think I did. and then bring down is the last step. Multiply. Shoot. The problem was wrong. It should be cubed. So we actually need an x squared. So it should be 2x cubed, and then 2x squared times 4 is 8x squared. And then subtract, there we go. X squared. So we multiplied, we distributed, we subtracted, and now we're bringing down. X times this x times what is x squared? Well, x. So we multiply, which will actually get us down to negative 7x. Bring down. And finally, so this was x. And then we have x times what is negative 7x. And the answer to that is negative 7. So we put in negative 7, multiply, subtract, which that cancels, and then this actually gives us a 2. So when the remainder, this is called the remainder. If we go back up, I meant to talk about some of the vocabulary. So this is the divisor, this is the dividend, and this right here is the remainder. We hope it's 0 because that means it factored evenly. And then this right here is called the answer, or the quotient. So if we go back down to the one we're doing, the remainder is not 0. So that means that x plus 4 is not a factor of this cubic, and we failed to factor. And when that happens, you have to put the remainder up here too, which is just the excess number divided by what you're dividing by, which is called the divisor. And this would be the quotient, or the answer. Let's do one more, and a special rule we have to do here. X cubed plus 0x squared plus 0x minus 64 is the same as the top over there, right? I mean, I just added zeros. We need to do that in order to keep ourselves lined up. So I'm going to go ahead and write that in here. Okay, and we're going to do the process one more time together. So x times what is x cubed? X squared. So multiply, so we did the division question. Now we multiply, subtract, bring down. Multiply, subtract from both, so this actually ends up being positive. Bring down the 0. And then another question. X times what is 4x squared? 4x. So we put 4x here, the plus, multiply, subtract, which will flip that to be positive 16x, bring down. Final question, x times what is 16x? Notice I'm just focusing on the first part, because that's all we need. We just need to guarantee that that matches, and then we'll make progress. This is just 16. So we get this, which is perfect because those are the same. So you get 0. So our solution then would say that when we long divided that dividend, we got the divisor times the quotient. So we broke down a cubic into a linear term times a quadratic term. So that's the purpose. Yeah, we should be able to know how to do it, but this is really what we need to take home, right? We've taken a cubic, which is hard to break down, and we've done it. And we just needed to know one of the terms, and you can get the other. Normally, you would need the difference of cubes formula, which is a formula used to factor cubics that look like this, but we don't need it if we know that this is going to divide evenly. So later we're going to test and see using the rational root test, how do we find these factors to divide by so that you can actually do it? Because it's no good